Can I ask once again? Can you hear me?
Yes, sir.
Okay, thank you. Anybody has a question? Shivansh, you have anything? Okay. So let us move forward. With what we were a little more advanced topics on machine learning. So let me ask you, if you had an assignment where you were to predict the housing prices, okay, and you had how many input features did you have? How many features did you have in that data set? कितने थे? Anybody remember? कितने थे? How many input variables did you have? Anybody remembers that or no? You don't have to be exact. Okay. So, were all those 10 features important? As far as modeling, predicting the housing prices is concerned? Not all were important. Okay. So, in your case, you had 10 features. Okay. We found that not all were important. Okay. One of the first exercises in the book that they covered was to plot. If we were trying to see a linear relation, and drawing a scatter plot matrix is a very good way of seeing whether there is a dependence or not. So scatter plot matrix. Did you plot this in the assignment? Where all the different variables were plotted with each other with respect to each other, or maybe so if you have feature 1 x1 and your housing price y, okay, the second was x2 y, x3 y, x4 y. A scatter plot like this may help you. Do you think it will help you in determining whether something affects the price or not? Will it? What do you think? It will. Okay. So hold on a minute. So if let us say you get y, the scatter plot of y versus x1 looks something like this. Okay, what can you say about the relationship of y on x1? Means, will x1 affect y or no, if it looks something like this? Can you see the dots or no? Dots दिख रही हैं या नहीं दिख रही हैं?
Yes, sir.
Okay. So what do you think? Is y dependent on x1? Do you think we should include x1 in our final analysis, final model that we create? Should we include x1 or should we not include x1?
That is a constant.
Yeah, let us forget about everything else for now. Okay. Let us only think about x1, whether x1 should be included in the final model for predicting housing prices or not. That is my question.
Shouldn't,
Dipanshu, why?
sir, because the mapping of y doesn't make any particular pattern.
With x1. So it might not be a bad idea to remove x1. Okay. And if you see something of this kind, let me make bigger dots so that, okay, if you see y versus x2 which looks something like this, do you think we should include that in the final model?
Yes, Yes, sir.
We should. Okay, so that is, so manually you could possibly come up with, and the reason you would want to remove many of these features, okay, one is that if you remove, so why would you want to remove these features? Why remove features from the final model? Okay, one is that your prediction might become more accurate. Okay, your prediction might become more accurate, because it is increasing complexity, and but it is not really helping in predicting something. Okay, so the prediction may become more accurate, so that is why you may want to remove it. Another important thing is interpretability. What is interpretability? And if you had 10 features, it is very hard to, if you come with a model for a human being to explain many of the phenomena. Okay, if you have 10 features, but if you have only 2 features, it becomes much easier. Okay, so you want to reduce the complexity as much as possible to increase the interpretability. Okay, so obviously manually you can do these things. It is all right. You can do that, but your life is going to be very hard if you have hundreds of features and you want to get rid of, uh, reduce the number of features for either of these two reasons. Okay, so we have to come up with a more systematic method for reducing the number of features. Okay, so one of the first ones is subset selection. Okay, so again our let me tell the name. Yeah, and the first one within the subset selection is the best subset selection. Okay, so if you have, let us say, p features, okay, p features, how would you go about, and we are going to use the approach that we introduced in the last class, which is cross validation. Okay, so we are going to verify using cross validation whether my particular uh, subset of features that I have chosen is the best. Okay, so we are going to, so how many subsets can you have? How many subsets can you have within p features? कितने subsets हो सकते हैं मेरे पास? Anybody? बताओ. So we'll choose k out of these p. Okay, and what can be the values of k? K can be 1, 2, 3. Okay, so choose k out of these p. Okay, choose k which can take these values up till p. Okay, so how many total? So if you were to choose k is equal to 1, how many subsets can you make? If you choose k is equal to 1, it will be p c1, where c stands for combinations. Okay, p c1 or p c k is equal to p factorial over k factorial p minus k factorial. Okay, so this is the definition of p c k. So p c1 plus, how many combinations can you make? If you had two, if you were to choose 2 features out of those pi p, pc2. Okay, so on and so forth until p c p. Okay, so what will be the sum of all of these? So how many combinations will you have? How many subsets will you have? कितने सबसेट्स हो जाएंगे हमारे पास?
Two to the power p minus 1. That.
Obviously, calculating this is not that straightforward, but doing something else is more straightforward. What is that? What can you do? Medha, any idea? How can we find out the total number of combinations that we have here? Total number of models?
Sir, 2 to the power p minus 1 ही होगा शायद से.
सही है, मैं मना नहीं कर रहा, लेकिन कैसे आया?
सर मतलब इसी को सॉल्व कर दिया. वो मतलब 1 ऐड करके वो 1 plus 1 to the power p minus 1 बन जाएगा. वैसा वो बाइनोमियल एक्सपेंशन वाला है.
कैसे इसको?
मतलब इसमें एक 1 ऐड कर देंगे तो 2 की पावर p बन जाएगा वैसा.
कैसे 2 की पावर की p क्यों बन जाएगा?
मतलब फिर वो जब एक्सपेंड करते हैं a plus b to the power n तो ऐसे ही करते हैं ना, n c1 a to the power n ऐसे करके. तो a और b दोनों को 1 रखेंगे तो 2 की पावर p बनेगा.
नहीं, वो सही है, लेकिन ये कहाँ से आया कि ये जो है दिस इज इक्वल टू 2 टू द पावर p? सो ही इज सेइंग दैट दिस इज इक्वल टू 2 टू द पावर p. वेयर डज दैट कम फ्रॉम? एनीबॉडी?
इसको 2 to the power p को अगर 1 plus 1 to the power p लिखकर और बाइनोमियल एक्सपेंशन करें तो यही आएगा. या सिंपली हम सोच सकते हैं सर कि हमारे पास p फीचर्स है, हर फीचर को सिलेक्ट करेंगे या नहीं करेंगे.
हाँ, that is a more intuitive way of doing this. Yeah. So if you have p features, okay, so your any particular so you can, so how many combinations can you make? So if you have the first feature, that can be either be present in your model or can not be present on the model. Okay, what about the next feature? So first feature can be present or cannot be present, means may not be present. Second feature may be present or may not be present. So multiplied by 2, multiplied by 2, multiplied by 2. So you get 2 to the power p. And why do I do minus 1? Minus 1 क्यों कर रहा हूँ? Because this contains one such possibility where ये जो हमने सारा multiplication लिखा है उसमें क्या है, हमारे पास एक ऐसी possibility है जो जहाँ पर क्या है,
सारे नहीं सिलेक्ट करें.
एक भी select नहीं किया है. Okay, none of them has been selected, which is not allowed. Okay, we have to select at least one feature. Okay, so that is why we do 2 to the power p minus 1, which turns out to be equal to this quantity. So this comes out to be, this is equal to 2 to the power p minus 1. Okay, so you'll have how many models? You'll have to create how many models now? You'll have to create 2 to the power p minus 1 models, and you have to choose the best one out of them. Okay, and we add a little more systematic procedure to find that. Is that we choose one k, okay, and we'll have now within, so once you have chosen that k for a specific k, how many models will you have for a specific k? You'll have pck number of models. Okay, you'll have pck models, and for those specific out of those specific pck models, we'll choose the best one. Okay, choose best and call it model mk. ठीक है? How will you choose the best one? You will have pck different models. Okay, if we are choosing any specific k. Okay, and how will you choose the best one out of those pck models? Using what? क्या करेंगे? Cross validation. Okay, so you will choose the best using cross validation, CV. Okay, and call that particular model, whichever the best one comes out to be, as mk. So after going through this procedure by choosing different values of k, you will have how many models? You will have m1, m2, mp models. Okay, these will be your models, and then finally what do you do? क्या करेंगे हम? फाइनली क्या करेंगे? हमारे पास p different models आ गए, इनमें से again we'll choose the best one using cross validation. So choose best out of these using cross validation. Okay, and finally you can verify using your test set. Okay, So this is called as the best subset selection. Obviously, it is all right, means you can do this, but this is a sort of a brute force approach or something called as exhaustive enumeration. Okay, it is called as exhaustive enumeration. What is exhaustive enumeration? You write down all the possibilities and choose which is the correct one. Okay, so it is obviously a very exhaustive approach, but what does it, what is the problem in using this approach? क्या परेशानी है?
टाइम कॉम्प्लेक्सिटी बहुत ज़्यादा है.
Yeah, so you are making how many models? You are making 2 to the power p different models and trying to compare all of them. Okay, which makes your life really hard. Okay, so we'll choose a little bit different approach from this one. Yes. So this is valid as long as your p is small. Okay, if your p is small, a reasonably small number, if p is 1,000, your life is going to be hell if you choose this methodology for finding out the subset, which gives you the best prediction accuracy. Okay, so the next one is called as stepwise selection. Okay, again, this is part of subset selection. Stepwise subset selection. Again, stepwise step subset selection is divided into 2 parts: forward and backward. Okay, so let us see what do we do in forward stepwise subset selection. What do? We start with what? Any idea how would we might do this? क्या करेंगे हम? We start with one, then we add the second one, then we add the third one, and we keep on doing that. क्या करेंगे?
We will select first and second, and we will compare which is better. If it is going to be better,
Hmm?
so we can select first subset and then.
So we'll start with k is equal to 1. Okay, let us talk about forward for now. We start with k is equal to 1. What do? We try to find out the best model with k is equal to 1. ठीक है, इससे हम बेस्ट मॉडल निकालने की कोशिश करते हैं विद k is equal to 1 यूजिंग दिस पर्टिकुलर, इस जैसे यहाँ पे किया था हमने सेम तरीके से विल फाइंड आउट द बेस्ट मॉडल. ओके, विद k is equal to 1 लेट अस कॉल दैट एज m1. ठीक है, best model with k is equal to 1. Next we are going to do choosing this as the starting point. Okay, once the best model is chosen, we have already decided which of the predictors, let us call that predictor as क्या बोलें उसको, P1 सही नहीं है क्योंकि P1 हमारा कुछ हो सकता है. Okay, let me call that as P1 prime. Okay, here, so please understand that initially your features were P1, P2, P क्या थे? Oh no, they were not P1, P2. They were X1, X2 and XP. Okay, let me call this feature as X1 prime. What is X1 prime? What is X1 prime? X1 prime corresponds to the feature for which gives you the best model. Okay, is that all right? ठीक है. So we have chosen one feature X1 prime. Okay, which may be any of these x1, x2, so on and so forth. Okay, now this becomes fixed. Okay, once your algorithm has gone through the first stage, your x1 prime becomes fixed. Means that it is going to stay in your model throughout. Okay, the future models are definitely going to include this. So now the next step is going to be choose k is equal to 2. Okay, what is k is equal to 2 going to be? K is equal to 2 में क्या क्या components होंगे? x1 prime तो definitely होगा. Okay, one of the features is definitely going to be x1 prime. Okay, you may, and you will have one unknown feature which will be calculated using this previous methodology. What is the previous methodology? You'll keep adding more. What? क्या करेंगे हम? अब हमारे पास कितने बचे हैं? How many features are remaining? P minus 1 features. Okay, out of those P minus 1 features, you will add one more feature. You will obviously now have P minus 1 models. You will create P minus 1 models and you will choose the best one out of them. Okay, once you choose the best one, that model is going to be called as M2, and the features of that particular model M2 are going to be x1 prime and x2 prime. Okay, so please understand that this x1 prime is the same as this x1 prime. Okay, so this x1 prime, the model which was giving me the best accuracy in the first stage, is going to stay throughout. Okay, and finally we'll move to k is equal to what? P will give me x1 prime, x2 prime, xp minus 1 prime, obviously xp will, or xp prime, let's call that. So you will have the final model will have all the different features. Okay, mp will have all the features. Okay, they will be in different order. Okay, they will be not in the same order as we previously had, but they will be essentially the same p features or p predictors. Okay, so what do you do now? Once you have found out that there are p different models, okay, p different best models for each number of predictors, what do? You are going to do, the final stage is going to be to compare. Again, we'll compare m1 to mp again. Okay, we have, like we did here, we are going to compare all of them and then find out the best one. Okay, any disadvantage of using this methodology? Any advantage? Let us first talk about the advantage.
Time complexity better.
Yeah, we have much better time complexity, because how many models are we creating, comparing over here?
T square.
Here we had, how many models we created? We created p models over here. In this case, how many models did we create? P minus 1. Okay, so on and so forth. So we are, the complexity is going to be of the order of p squared. Okay, here it was 2 to the power p, so much higher than that. Okay, so that is an advantage. What is the disadvantage?
These are biased, like x1 is fixed in some model is different.
क्या बोल रही हो? मैं समझ में नहीं आया.
So like if x1, we have taken x1 value from the first best model we got.
Yeah.
In further models, it may not be the best.
Yeah, that is correct. So when we choose only one predictor, we got x1 prime as the best predictor among those one predictors. But when you choose two predictors, it is possible that some x, let me call this as, let us say x1 prime was x4. Okay, let us say x1 prime was x4. Okay, x4 was the best out of the first, when we choose only one predictor. But let us say we started with k is equal to 2, not from k is equal to 1. Let us say we started from k is equal to 2. Okay, and we found out that if we have two predictors and we do our analysis using cross validation, we find that predictors number x3 and x5 give me the best accuracy. Okay, if I choose predictors x3 and x5, they give me the best accuracy, assuming not using this methodology, but we are starting from using something like this. Okay, using the subset selection. Best subset selection gives me that x3 and x5 are giving me the best accuracy among two predictors. So, but if we were to use this methodology, what will we get? हमें क्या मिलेगा? हमें x4 को choose करना ही करना होगा. Okay, which is not necessarily true. Okay, so this gives us a this particular methodology is not very robust in the sense of that I just showed you through an example. Okay, that a predictor which may be important or which may give the best accuracy in when k is equal to 1 may not, if you were to use an exhaustive enumeration sort of strategy, it may not even appear over here in k is equal to 2 or may k is equal to 3 or k is equal to p. Okay, we are choosing x4, but it is possible that this x4 may not appear. If we were to use this kind of strategy, it may not even appear anywhere at all. Okay, but if you are to use this forward stepwise subset selection strategy, then x4 has to appear everywhere else also. Okay, which may not be a very good thing to do. Okay, so your accuracy may suffer.
तो मतलब तो फिर तो ये गलत ही है पूरा.
मतलब हाँ, कह सकते हो एक सेंस में कि गलत ही है पूरा.
तो सर फिर तो वही है टाइम वही सबसेट सिलेक्शन में तो लेकिन टाइम कॉम्प्लेक्सिटी बहुत ज़्यादा
हाँ, इसमें तो बहुत ज़्यादा है ना, मतलब इनका तो कोई कंपैरिजन ही नहीं है.
तो फिर करेंगे कैसे?
So let us actually try to visualize what the time complexity difference is. So in this case, let us say p is 100. Okay, what is 2 to the power 100? कितना होता है? 2 to the power 10 is 1000. Okay, so 10 to power 3 and 10, so this is approximately 10 to power 30. Is that correct? ठीक है, ठीक है ना. 10 हमने एक बार ले लिया, 10 into 10. ठीक है, so this is 10 to power 30. What about this? If we had 100 squared is how much? 10 to power 4. कंपैरिजन ही नहीं है यार, आया समझ में. तो ये this might means even if this does not give you the best solution, it might not be a bad strategy. Means as within the constraints of our computational power. ठीक है ना. It is something, not nothing. But compared to, there is no comparison between these two. ठीक है.
Yes, sir.
So we'll move on to the third one among the subset selection. I'll erase this. Let us talk about reverse.
सर वो स्लेट वो लिखा गया है सर सबसेट सिलेक्शन के पहले स्लेट
Stepwise.
ओके.
ठीक है. So any idea what we would do in reverse subset selection? क्या करेंगे?
We will select all the features and then we will try to.
We will select all the features. Can you hold on a minute? I have a courier that I need to pick up. Yeah, somebody was asking a question. Can you repeat? Can you hear me?
I was not asking a question. You asked the question.
Okay, whatever it was, can you remind me what was going on? Yeah.
Actually, you asked what will we do in reverse.
Yeah, 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 yeah.
So I was just saying that first we will select all the features and we will try to find the best model out of it, and then we can go in reverse direction, that we can drop some features which are not important.
Yeah, good. So we'll start with k is equal to p. Find out the accuracy at k is equal to p. Let us call that as mp. Okay, let us start from the other side. Okay. Then we choose k is equal to p minus 1. Now what is going to happen in p minus 1? How many models will we create with k is equal to p minus 1? Vishesh, how many models will we create?
2 to the power p minus 1.
नहीं नहीं, केवल k इज इक्वल टू p माइनस 1 जब चूज करेंगे तो कितने मॉडल्स क्रिएट होंगे हमारे? p माइनस 1. ठीक है. सो व्हेन k इज इक्वल टू p माइनस 1 यू विल हैव p माइनस 1 और p होंगे यार. p c p माइनस 1 होगा ना. p c p माइनस 1 क्या होगा? या फिर वैसे भी सोचें तो वी कैन ड्रॉप द first feature or the second feature or the third feature, so we have p possibilities of dropping features. So we'll have p, this will give me p models, no Vishesh? Or p minus 1 p देगा? Yeah, we are dropping one feature out of the p features. So how many possible models can we create? नहीं यार, p में से एक गिरा रहे हैं तो कितने तरीके से गिरा सकते हैं हम? वन. हाउ कैन वी? हैं? p है ना, ठीक है ना. और अगर ज़्यादा दिमाग नहीं लगाना है तो ये लगा सकते हैं पी सी पी माइनस 1. सो इट इज गोइंग टू बी p फैक्टोरियल डिवाइडेड बाय p माइनस 1 फैक्टोरियल माइनस इंटू p फैक्टोरियल, सॉरी 1 फैक्टोरियल. 1 फैक्टोरियल इज 1, सो p फैक्टोरियल ओवर p माइनस 1 फैक्टोरियल इज p. ठीक है. So let us say that the feature dropped in this case. This gave me the model. So best model out of this was m p minus 1. ठीक है. And we keep on going until k is equal to 1 and we have m1. Again we'll choose the best model out of these and say that is. So this has a little more advantage as compared to the forward methodology, is that there is a less likelihood of losing out on important parameters. Okay, whereas in the forward case there was a very strong likelihood that if you are going from 1 to 2, that you are in case of two features, some other two features were more important than the feature chosen in the first stage. Okay, so here the likelihood of that is less. But do you see any advantage of forward as compared to backward?
सर मतलब फॉरवर्ड में हमारा वही फिक्स हो जा रहा था ना कि पहला वाला लेना ही है, बट इसमें वैसा कुछ फिक्स नहीं है.
हाँ, नहीं, बट फॉरवर्ड की कोई एडवांटेज है एज कंपेयर टू बैकवर्ड? बैकवर्ड की तो मैंने बता दी अभी. फॉरवर्ड की कोई एडवांटेज है? डेटा सेट के साइज को देखें. Let us say we are trying to compare. So n is your data set size. Okay, if n is smaller than p, then do you see any advantage of using forward as compared to backward? If the number of data points in your data set is smaller than p, number of predictors, क्या होगा?
मतलब इसमें हमें बड़े जिसमें ज़्यादा फीचर्स ले रहे हैं उसके ज़्यादा मॉडल्स कंपेयर करने हैं, तो शायद से वो ज़्यादा टाइम टेकिंग.
So please understand that if your n is smaller than p and you are choosing any model with p predictors, what is going to happen? You will not get a unique solution. Do you agree? ठीक है ना, यूनिक सॉल्यूशन के लिए हमें एटलीस्ट n इज इक्वल टू p चाहिए, तब भी हमारा यूनिक सॉल्यूशन गारंटीड नहीं है, बट देयर इज अ पॉसिबिलिटी दैट यू मे गेट अ यूनिक सॉल्यूशन. ओके, बट इफ n इज लेस देन p देन यू विल नेवर गेट अ यूनिक सॉल्यूशन. ठीक है ना, बिकॉज द नंबर ऑफ वेरिएबल्स इज, नंबर ऑफ वेरिएबल्स कितने हो गए हमारे, n if n is less than p, number of variables is p. Okay, and number of equations is n,
Smaller than number of
number of variables, so you will never get a unique solution. Okay, so if we use the forward methodology, okay, if you are using forward methodology, obviously you cannot so your k cannot be greater than n. Okay, because then you will not get a unique solution. Okay, you will only go from k is equal to 1 to n when you are applying the forward strategy. Okay, obviously the backward strategy cannot be applied at all if n is less than p, because you will not get unique solutions in this case. So it's obviously going to be, your life is going to be a little difficult. Okay, I think Vinod has a class at 4 o'clock, so I will join the same link that I sent you again. Okay, can you hear me, Umama?
Yes, sir.
Okay. Okay, we after the class I'll join on that link, but we'll not continue here. We'll continue on the other link at after 4 o'clock. So you have to choose. So your k cannot be, क्या बोल रहा था मैं? Cannot be greater than n. Okay, this is not allowed. Okay. So in reverse you cannot even follow the whole procedure, but in case of forward subset selection you can follow through the complete procedure. Okay, so forward subset selection might be the best strategy that you have in a scenario where n is smaller than p. Is that okay, Shivansh?
Yes, sir.
Okay, आज बाकी लोग कहाँ चले गए? जो सबसे रेगुलर हैं वो लोग गायब हैं आज. क्या हो गया? मैं लेट आया था इसलिए छोड़ के चले गए, क्या हुआ? एनी आइडिया?
वैष्णवी शायद से बीमार है सर.
ओके,
बाकी तो आए हैं सब.
Tanvi is also not here, I think.
तान्या,
Oh, sorry, yeah, Tanya, yeah.
I lost.
No, that's fine, don't worry. Because those two are the most regulars, and Dipanshu also. He is there. You are also a regular, but you have been missed a few classes because of your sickness. Anyway, so any questions? Anybody about this? So this might be a good strategy to apply when you have number of predictors which are larger than the number of observations in your data set.
तो इसमें मतलब एरर क्या है ओवरऑल, अगर बैकवर्ड लगा के ये एक्यूरेट रिजल्ट दे देगा क्या?
बैकवर्ड लगा ही नहीं सकते ना, क्योंकि हमारा सोल्यूशन ही नहीं आएगा.
नहीं सर, n ग्रेटर देन p के लिए बोल रहा हूँ.
n ग्रेटर देन p के लिए,
हाँ,
तो उसमें क्या परेशानी है? तो यही लगाएंगे ना.
n ग्रेटर देन p में फॉरवर्ड में तो तब भी दिक्कत आ रही थी ना वो जो.
हाँ, तो रिवर्स लगाएंगे ना उस केस में.
हाँ, तो मतलब रिवर्स तो फिर एक्यूरेट आंसर दे देगा.
हाँ,
तो अच्छा मतलब
मैं वही कह रहा हूँ. सो इफ n is greater than p, apply reverse. Okay, if n is less than p, then apply forward. That is what I am trying to say. Is that okay? ठीक है या नहीं है?
yes sir.
Okay.
सर अगर computational complexity का होना हो तो तब तो फिर जो first step वो लगा.
Yeah. Obviously, this is the best. We call it also the best subset selection. Best is in its name. Okay. It might not be the most efficient way of doing things, but it is the best because you are going through the whole set.
सर बट ये रिवर्स गलत आंसर दे सकता है क्या? मैं ये कह रहा था कि अगर बेस्ट सबसेट सिलेक्शन और रिवर्स को कंपेयर करें.
हाँ, कोई इतनी unthinkable बात नहीं है वो. So like we were going in the forward direction, it is also possible that we may go in the opposite direction. जैसे if I am at stage, मैंने ऊपर से start किया. Okay, I started from p predictors and I'm moving down. When k is equal to 2, let us say my chosen one was x4 and x6. ठीक है? If k is equal to 2, the best model was the one which had predictors x4 and x6. Assuming that we are using this, okay, and if k is equal to 1, then the best model was x5 with the predictor x5. ठीक है, अब हम k2 k is equal to 2 से k is equal to 1 पे जाएंगे. दिस इज यूजिंग दिस मेथडोलॉजी बेस्ट सबसेट सिलेक्शन. ठीक है, ये हमारा बेस्ट सबसेट सिलेक्शन से आया ये दोनों रिजल्ट्स. ओके, फ्रॉम यूजिंग दिस स्टेप वाइज सबसेट सिलेक्शन ऑल्सो आई गेट दिस वैल्यू. ठीक है, ये आ गया मेरे पास, चलो ये ठीक है. बट आई विल नेवर रीच हेयर. पहुंच सकता हूँ मैं?
नहीं सर.
ठीक है, आया समझ में? तो भी ये बेस्ट मतलब इसके कंपैरिजन में बढ़िया नहीं है इफ़ यू हैड दैट कंप्यूटेशनल पावर. ठीक है, ओके, देन वील स्टॉप एंड वील कंटिन्यू in the next class. Okay, if anybody has a question, I'll answer that. We have couple of minutes. I don't want to start a new topic because
Friday तक का syllabus आएगा midterm में.
yeah everything. If I need मिड टर्म कितनी देर का रखें? 1 घंटे का, 1.5 घंटे का?
आप पे
नहीं, मेरे पे तो है, मैं तुमसे पूछ रहा हूँ.
सर वो फिर अगर 2 पेपर होंगे तो फिर 1 घंटे में नहीं होगा.
नहीं, 2 वाला तो 1 में नहीं हो सकता. या मैं सोच रहा हूँ 2 पार्ट्स में कर लें उसको. एक शाम को ड्यू कर दें, एक सुबह. तुम्हारा एग्ज़ाम है ना एक दोपहर को 12 बजे?
यस सर, एक बार देख लो कॉन्टैक्ट.
Yeah, I know it is 12 o'clock. You are 333 means whatever the code is. Your exam of this course is at 8 o'clock in the morning on Wednesday, I think. Wednesday को ये ना?
यस सर, वेडनेसडे को 8 से 9 है.
Yeah, it's in 9 or 9:30. Depend. So I was thinking maybe if we split it into 2 parts, maybe the programming part can be due in the evening so that you have time to prepare for the next exam if you want to. Which one would you prefer? Everything at once or divided into 2 parts?
सर अगर एवरीथिंग एट वंस होगा तो फिर प्रोग्रामिंग नहीं आएगी सर.
पता नहीं यार, अभी भी मेरे को लग रहा है थोड़ा तो दे देना चाहिए. या तो 1 घंटे का एग्जाम होगा. अगर इफ वी हैव ओनली हैंड रिटन देन इट्स गोइंग टू बी 1 hour. आई डोंट नो व्हाट टू डू. लेट मी think a little more. Let me finalize it. Okay, we'll make it 45 minutes each. Okay, and it will be all at once. So let us say so.
तो सर हैंडरिटन ही ले लीजिए पूरा.
नहीं, थोड़ा तो देना चाहता हूँ यार. ठीक है, so 45 minutes handwritten and 45 minutes or maybe 40 minutes. Okay, I'll give you a 5-minute break in between and 40 minutes for the programming part. ठीक है, so at 8, what is the date? Can somebody tell me? 8 a.m.
30 सेकंड.
Huh? 22nd? 9:21, 8 a.m. So the handwritten part will be due at 8:45 and the programming part will be due at 9:30. Okay? So that is how we are going to divide it.
Moodle पे.
Yeah, Moodle. Like last year.
Yes sir.
You all have taken my class, no? Is there anybody who has never taken my class? I don't think there is anybody. Means by class I mean the Moodle, the online class. I think everybody has taken. You were all in my class last year. Anybody else has any questions? If not, then we'll stop.
चलो 5-6 मिनट अपलोड करने के भी दे देना 5 हैंडरिटन.
Okay. So this is due at 8:50. ठीक है. So let me make it 50 including your whatever uploading you require. So this will be due at 8:50 a.m. and this will be due at 9:30 a.m. ठीक है. Any other questions? Medha, can you type this up and send out an announcement on the Moodle website? Huh?
So I will.
Okay, thank you. Okay, bye bye. See you on Friday.